This next video I make is probably going to put me out there because I'm actually stretching my logic with this one. But I actually refuse to accept the traditional belief in science that birds see even more colors, let alone tens of millions of more colors than humans do. And I know that this may actually be quite heresy and unorthodox to a lot of what people seem to believe. The reason I have come to this conclusion is because, okay, you see, color, as much as any other type of information, it takes brain power in order to develop. You see what I'm saying? For example, the mantis shrimp. And I will be putting some information down there if you want to take a look at it. There'll be a video about how mantis shrimps actually don't see color as good as we might have thought. They have a lot of color receptors, much more than we do. But the color receptors kind of flood each other out a little bit. And what I've also discovered is that humans can actually see ultraviolet light when the natural lens is removed from the eye. And some may say that, well, yes, but we only see what our brain can comprehend. Exactly. We see what our mind can comprehend. We see through the blue color receptor, as it's called. That, we see UV light through the ultraviolet. The ultraviolet spectrum is seen through the blue color receptor because that's the only one we have. Am I right? But there is actually some indication, and I'll show you down below. There's going to be a link showing this man who got his eyes fixed with cataract surgery in a particular way where he was able to see into the ultraviolet. And they say that humans' third color receptor, the blue color receptor, is actually even more sensitive to ultraviolet light than it is blue light. But we cannot see it because our eyes right here have a yellow lens blocking out most of the receptors. And I also want to point out that there is a little bit of evidence that our blue cone is actually somewhat a mixture between the bird's blue cone and ultraviolet cone. Meaning they may just have two cones for the same thing, just like a mantis shrimp does. And I have an example right here of the bird vision right beside of the human vision. And the bird vision, their blue cone stops at 445 nanometers. Ours stops at 424 nanometers. It's a lot further out there. And their fourth cone, the so-called ultraviolet cone, goes all the way to 370 nanometers, about what we see when we get cataract surgery. And what do we see right here? The blue cone that we have is smack dab between the ultraviolet cone and blue cone that the bird has. Meaning that, in my opinion, birds do not have a red cone, a green cone, a blue cone, and an ultraviolet cone. They have a red cone, a green cone, a cyan cone, and a blue, aka ultraviolet cone. And so this is not orthodox science. I do know this, but just like the mantis shrimp that we thought actually saw more colors than we can ever imagine, I think the same thing is going on with the bird. And also there's a woman who claims to be a tetrachromat. But if you listen to what she actually says, her color vision isn't much different than ours. She claims to see 100 times more colors, but she has yet to name a single thing that she can't describe in her paintings, meaning she sees quite the same as we do.